Here we have to determine the oxidation number of the central metal atom or ion in each of the following complex. We have 10 complexes. Let's start with the first one. So this is our complex ion. We want to calculate the oxidation number or oxidation state of this central metal ion. So how to do that? Let us denote that one by X. Plus 4. What is the charge carried by NH3 molecule? It is 0. And then equate it to the charge on the coordination sphere, that is plus 2. So from here our X would be what? Plus 2. So plus 2 is the oxidation state or oxidation number of the central metal ion, okay, of this one. In the same way, for the second example, follow the same step or same procedure. We denote that one by X. For iron, plus 6 into minus 1, because minus 1 is the charge carried by this Cn molecule. Equate it to the negative charge, minus 3. So from here you will get your X to be what? Minus 3 plus 6, you get plus 3. So plus 3 is the oxidation number of this central metal ion. We come to this one. Again, X plus 4 into 0. What about this one? The charge carried by this counter ion, this one, okay, SO4 2 minus, it is minus 2 because it exists as SO4 2 minus, and for that one would be NH3 4 2 plus. So now you have to equate this one to 0 because it is neutral. That's why you have to equate it to 0. So after that, what is your X? Take this one to the side, it is plus 2. So plus 2 is the oxidation state or oxidation number of this central metal atom here. Now here we want to find for this one, so let that one be X. 6 into minus 1. Equate it to minus 4. So what would be your X? Minus 4 plus 6 would be how much? Plus 2. And then here 3 into plus 1, because the charge carried by this potassium is plus 1. And then plus, we want to find for this one, it is X plus 3 into how much? Look at this one. This one is a didentate ligand. This one, it is of this form, or minus 2, like this, okay, minus 2. So 3 into minus 2, equate it to 0 because it is neutral. So what would be your X? Here you have plus 3 and minus 6. Plus 3 with minus 6 gives you minus 3. If you take that one to the side, it gives you plus 3. Now for this one, X plus 4 into the charge carried by this one is 0. Equate it to 0. So your X is 0. This is the oxidation number of this central metal atom. Now we come to the seventh one. X plus 5 into what? 0. The charge carried by NH3. And then what about Cl? It is minus 1, okay, minus 1 is the charge carried by this one because it accepts 1 electron. Equate it to plus 2, the charge on the coordination entity or coordination sphere. So from here your X would be how much? Here it would be 0. And then minus 1 with plus 2, it will be plus 1, right? So that will be plus 3. So your X would be +3 in this case. 4 into +1, the charge carried by potassium, plus X plus 6 into -1 for Cn, equated to 0 because it is neutral here. So we get X to be what? +4 with -6, we get -2, and then if we take it to this side, it becomes +2. Okay, or if you want to calculate in another way, you just can do like this. This one dissociates as 4K plus and Fe Cn 6 4 minus. If you don't want to calculate in this way, you can also calculate simply by taking this one. That is, you write X plus 6 into -1 equated to -4. So it gives you +2 only. Okay, we come to this one. We want to find for platinum, so let that one be X plus 3 into 0. For Cl it is -1 equated to 0. Here we don't have any charge. Okay, so what is your X? It is +1. So it is in this way that we are finding the oxidation number or oxidation state of the central metal, atom or ion in these given complexes. Sorry, there are actually only 9 here. I've made a mistake here. Okay, so that's all.